polynomial division with a missing term. In this example, this is a degree 3 polynomial divided by a degree 2 polynomial. We're really going to look at the dividend first. We see this is degree 3, the next term is degree 2, and then we go straight to a degree 0 term after that. So that missing term that we're referring to is the x to the power 1 term. When we say that we need to replace that with a 0, what we mean is that we're going to fill in a 0 x to the 1 for that term, because everything will be easier if we can line up the like terms and therefore keep every power from the highest power on down to 0 represented somewhere in this dividend. So when we set this up, I'm going to have x squared plus 2, which is my divisor on the outside. I'm not so concerned about a missing term in the divisor, because I can choose where to write each term when I'm getting ready to do the subtraction. I'm primarily concerned about a missing term in the dividend. So I'm going to write this as 3x to the power 3 minus 2x to the power 2. This is where I'm going to fill in that 0x to the power 1 term. And then we'll finish with that plus 3, which is my degree 0 term. So I'm going to get ready to go ahead and do this polynomial division now, starting with first term divided by first term. So that is 3x to the power 3 divided by x squared, which gets me 3x as the first term in my quotient. I then multiply that 3x that I just calculated by the divisor, x squared plus 2, and I go ahead and distribute and write the result below my dividend. That becomes 3x to the power 3. The next term is going to be plus 6x to the power 1, so I'm going to write that over here to line up with my x to the power 1 term. And in this next step, I am ready to subtract. Of course, as I do this subtraction, I need to make sure that I distribute my sign to both terms, so that my first term is 3x cubed minus 3x cubed. Those drop out. Next, we have this negative 2x squared, which is going to drop down. Next we have 0x minus positive 6x, so that becomes minus 6x. And this 3 here again will just drop down. So I am again ready to find a term in the quotient, and I start the process over again, taking first term divided by first term. So negative 2x squared will get divided by x squared to get negative 2 as my next term. Then I bring down that negative 2 that I just calculated, and I multiply it by x squared plus 2 to get negative 2x squared minus 4, again choosing to line up the terms with the like term that they will naturally combine with each time. Now that I'm ready to go downwards, I am again subtracting. And this time we will have to be particularly careful with our signs. We have a negative minus a negative. With the first one, it's not so hard because they always drop out if you've done the previous steps correctly. The negative 6x still comes down. And now we have positive 3 minus negative 4, which I'm going to read as positive 3 plus a positive 4. So this becomes now plus 7. Looking at my result, I can see that I have a degree 1 polynomial down here. 6x to the 1 plus 7 is degree 1. Whereas my divisor is degree 2, my x squared plus 2 over here is degree 2. So since I have gotten a result that is strictly lower than the degree of my divisor, this means that I am done. At least I'm done with this process. It's now time to write my answer in the form quotient plus remainder over divisor. So remember, this expression up here is my quotient. My end result down here is the remainder. It is possible for the remainder to be a whole polynomial rather than just a number. And my divisor, as I mentioned before, is the x squared plus 2. So I'll write my final answer as 3x minus 2 plus my remainder of negative 6x plus 7 over my divisor of x squared plus 2.